Right, is one of those pieces of information easier to find than the other? Volume, right? Hey, what is the volume? Let's do that one first, real quick. Okay, so the volume formula for this is what? It's a pyramid, so it is 1/3 B times H, where B is the area of the base, H is the height of the solid. Okay, and so what is our base shape here? A square, so I'm going to use S squared, the equation for the square. You can also say base times height. That's fine. Times H. So here's my generic formula. Now I can substitute in pieces of information. So what's the length of each side? 6. So we get 6 squared times, and what's the height? So 4. And so now if you substitute or continue to solve this problem, we get 1/3 of 36 times 4. 3 goes into 36 how many times? 12. 12 times 4 gives you 48. The units are centimeters. It's a volume, so we're looking at cubic centimeters. So when you look at that problem, the volume is a straightforward problem. Right? Surface area, not quite so straightforward. Any ideas on what you can do? So let's take surface area and figure out how we can build it. Again, you do have to, with pyramids, just find all the lateral faces or every face individually. And so here we're looking at a square base. Okay, so there's our square base plus how many triangular lateral faces? 4. And so rather than taking 4 of those individually, what do we know about each of those 4 lateral faces? They're the same because it's a square. So really what we could do is we could take our equation S squared plus 4 times 1/2 base times height. Okay, well, the base we know, right? So if we take one of these triangles, okay, so our length of our side is 6, so we can plug that in for S, plus 4 times 1/2, our base is 6. And what we need to do is find what the height is for that triangular lateral face, right? So that height, if I were to draw it here, just because perspective-wise it's a little bit easier to see, is this length right here. This is called a slant height. Right? It's for a pyramid, and cones will have these slant heights associated with them. So here is the height H. Okay, well, if I look at this height, is there a way that I can find what that measure is? Griffin? Perfect. So if we draw this right triangle here, we have one leg of the right triangle is 4, the height of the solid. This other leg is just half of the whole side length, so 3. So what's left for H? It's a 3, 4, 5 common triple, or you can use Pythagorean theorem to solve it. So we get our height to be 5. Half of 6 is 3. And then you just multiply this through. So 6 squared is 36 plus 4 times. And again, when you're multiplying these, it doesn't matter the order you multiply them. We'll talk about this a little bit later. But you could say 3 times 5 is 15, but it's probably easier if you just think of it 4 times 3 times 5. And again, you can move it in different directions. So possibly the easiest one, 5 times 4 is 20 times 3, 60. So if you take 36 plus 60, you get your answer 96. The units are centimeter. It's an area, which is a 2-dimensional measurement. So we get 96 square centimeters.